Good morning, all of you.
Good morning, sir.
Good morning, sir.
Yeah. We were supposed to start with electrostatics. Right? We have a collection of few good problems. By now, I believe the basic revision has already been done by all of you. You have gone for JEE mains 2 times and you have cleared JEE mains. So quite obviously, there's no point of going through the basics again, right? There is a circular disc and there is an electric field this way. The electric field ka value is given by E naught into 1 minus small r by capital R. Right? Find the flux through the disk. Find flux through the disk. Find flux through the disk. Yes. Consider an element of radius small r, thickness dr. So the field is in yellow color here. This is the field. Field into area will be d phi. This will be E naught into 1 minus small r by capital R. Area is 2 pi r dr. Integrate this from 0 to capital R. Should not be difficult. And the answer is pi epsilon naught r square by 3. Pi epsilon naught r square by 3.
Sir, it should be E naught.
Pi E naught, sorry, my bad.
Yeah, sir, it's
Yeah, my mistake. This is E naught. Can I proceed?
Yes, sir.
Suppose I have an infinite long positive charged wire here and another infinite long positive charged wire this way. Put it down. So that this is coming perpendicularly outwards. Find the force of interaction between them. One has a charge, linear charge of lambda 1. The other has a linear charge of lambda 2. Technically, these lines are called skew lines, SKEW. Skew lines, when they are perpendicular to each other, but not in the same plane. Consider an element dy at a distance of y. Because of this, the field will be like this. Take this as theta. This distance will be root over of y square plus r square. Can you tell me the value of the field? 2k lambda 1 by this distance. Root over of y square plus r square. This is the field on that small element. This field will have a horizontal component and a vertical component. By symmetry, I'll assume whole of this vertical component will cancel out the vertical component on the lower side. So if I take this as theta, this is theta, E cos theta into lambda dy will be my force. Will be my force. E cos theta or E lambda dy will be df cos theta. Either way, you take df here, df cos theta, E lambda dy into cos theta. No big deal. df will be 2k lambda by root over of y square plus r square. Now here this lambda is lambda 2. This lambda is lambda 2. Here this is lambda 1. The field is because of lambda 1. Charge is lambda 2. I'll put lambda 2 here. And then cos theta expression. Cos theta is adjacent side by hypotenuse. Y square plus r square. This into dy. Hope I didn't miss anything. I'm not concentrating. 2k lambda 1 by this. 2k lambda by r. R is the distance, right? Cos theta is this. Integrate this, you get the answer. Integral df 2k lambda 1 lambda 2.
Lambda 2 into y now.
Did I miss somewhere
Charge
something?
चाहिए ना.
Lambda 2 into dy.
Y. अच्छा, okay.
The charge on this will be lambda 2 into dy. Right, this is r dy upon y square plus r. This will go from minus infinity to plus infinity. Once you convert that in terms of theta, limits also will change accordingly. Or you can make it 2 times 0 to infinity. Tan theta is y by r. You people know the standard integration by now. Tan theta is y by r. Y is equal to r tan theta. Dy is equal to r secant square theta d. 2 times 0 to infinity, when I convert it in terms of theta, it becomes 2 times 0 to pi by 2. Can I proceed?
Yes, sir.
There are two identical bodies connected by a spring or spring constant K. This is fixed at O. Fixed at O. Length of the spring, unstructured length of the spring is there. Mass of this body is m, mass of this body is m. Two small identical bodies lying on a horizontal plane connected by an ideal spring. One ball is fixed at O. This is fixed at O. The other is free to move. The two bodies are given equal charge. The two bodies now are given equal charge. This is also given charge Q. This is also given charge Q. As a result of which, this will stretch by a distance of L. This is phase. They are given equal charge. So as a result of which, the other body will move by a distance of L. Right? Determine the frequency of the system due to charging of the bodies. Find the frequency of oscillation. Find frequency of oscillation. Find frequency of oscillation. One second, listen. The terminology used is, one second, make a correction. When you give a charge Q, the length of the spring increases two-folds. When charge Q is given, length of the spring increases two-folds. Length increases two-folds. What does that mean? What does that mean when it increases two-folds?
Double.
Double. So the new position where it comes to rest is 2L, right?
Extrema should be 2L, no?
Extremum will be 2L. Extremum will be 2L. So this is basically the equilibrium position now. Equilibrium position. At the equilibrium position, I will say KL is equal to KQQ by 2L whole square. This is at the equilibrium position. Do you people agree with that?
Yes, sir.
Now, from here, you slightly displace it by a distance of x. Every time for SHM, it's a standard approximation that x is much lesser than L. I should have given you that in the question. I missed that x is much lesser than L. Right? Now the restoring force will be KL plus x minus KQQ by 2L plus x whole square is equal to mass into acceleration. See if you are convinced. 2L plus x whole square in the denominator is equal to mass into acceleration. Now, I'll remove the lower part for me to do the simplification. Now you know this is KL plus x minus KQQ into use binomial expansion. Use binomial expansion 1 plus x by 12 whole to the power minus 2 into 12 and
-2 raised to -2.
minus 2, right? Will be equal to, or I'll bring this to the power 12 whole square here. This I bought it here. Mass into d2x by dt square. I'm damn sure you'll be able to do from here. Open up using the binomial expansion, neglect the higher powers of x, and tell me what is the answer that you're getting. You should be getting omega is under root 2k by m. Verify if you people are getting this or not.
तो दोनों के सेम है क्या?
हाँ exactly.
Oh no. I use the same symbol. Here k is spring constant. Here k is 9 into 10 to the power 9. To eliminate that confusion, I'll put it as 4 pi
4
epsilon.
pi epsilon.
Right. This is 4 pi epsilon naught. Don't cancel out this case. Right. Here k is spring constant. Here k is 9 into 10 to the power 9. You getting the answer?
Yes, sir.
Independent.
The first part, after expansion, the first element will get cancelled out. Use this equation. K Q1 Q2 K Q by 4 pi epsilon naught 12 whole square. This and KL will get cancelled out. Kx is equal to the remaining part.
Yes, sir.
Can I proceed?
Yes, sir.
Yes, sir.
You have a charge Q placed at the origin minus 2Q placed at A comma 0. Find the locus of all the points where the potential will be 0. Find locus of all points where potential is 0. Somebody typed it down, so that's right. Take some coordinate x comma y. This will be R1, this will be R. Now the potential there should be 0. KQ by R1 is K minus 2Q by R. K minus 2Q by R2. Sorry, make it. Then this is plus. Then this is plus. Should be equal to 0. Right? So from here, what do I get? 1 by R1 is equal to 2 by R. That means 1 by, how do I get R1? This total distance is A. This is X. This is A minus X. How do I get R1? This is Y. R1 will be root over of x square plus y square. What is R2 equal to? By the way, your condition is find out the point where potential is zero. Potential is zero. Now R2 will be root over of y square plus a minus x whole square. Agreed? Cross multiply, simplify, see what is the answer you are getting. You should be getting the equation of a circle.
हाँ सर
If I'm right, you will get x plus 2 whole square plus y square is equal to a square. If I remember the answer well. No, not a square here. You will not get a square. Just verify this equation is not correct. Simplify that and see what you are getting. Somebody typed the answer. 3x square plus 3y square plus 4ax is 4a square. Can I proceed? All of you got the locus to be a circle, right? You're supposed to get a circle. This is a thin rod which is fixed about the center. You have fixed a dipole of dipole moment here and switched on an electric field of electric field strength. A thin rod hinged at the center which can rotate in the vertical plane. At the top position, you have fixed a dipole, right? And then switched on a uniform electric field towards the right. Find the omega of the rod when it becomes horizontal. Find omega of the rod when the rod becomes horizontal. When the rod becomes horizontal, find the omega of the rod.
Length of the rod is given.
Length of the rod is given. L is the length of the rod. M is the mass of the rod. I forgot to give you people both. L and M. M is the mass of the rod. All you will do is change in potential energy. Delta U is equal to gain in kinetic energy. Now delta U will be loss in potential energy by default because you are gaining kinetic energy. Gain in kinetic energy. How do you know loss? U initial minus U final. Half I about O into omega square. About this it will be O. U initial minus P dot E. P and D are perpendicular. So I will not waste my time for this. Right, U initial is 0. Minus U final is minus P E cos 0. This should be equal to half I naught omega square. I naught is how much? ML square by 12. So quite a straight hit in this particular case. In a region where I have a uniform electric field, there is a dipole moment P placed. In a region where I have a uniform electric field, there is a dipole moment P is placed. Right? In a uniform electric field, parallel. Both of them are initially parallel. Find the radius of a spherical equipotential surface with the center of the dipole as the origin. Find, write down the statement, find the radius of a spherical equipotential surface.
So we can assume a short dipole, right?
Yeah, by default, dipole word whenever we use in our system, you will assume a very short dipole. In the exam, it will be told. We typed the answer actually. Listen. You will assume a spherical surface like this. From here, this is a point. From here, this is a point. Call this point 1, call this point. Now this is theta. What will this angle be? Pi minus theta, because this angle will be theta. Potential at 1, P cos pi minus theta divided by 4 pi epsilon naught r square. I'll call this r. Potential at 1, dipole moment cos pi minus theta. See, why is this pi minus theta? Because if this is theta, this angle is theta. But in a dipole, when I'm measuring the angle, I will take the angle this way, right? So if it goes to the second quadrant, that value will be pi minus theta. That is the potential at 1 due to the dipole. This becomes minus P cos theta by 4 pi epsilon naught r square. What will be the potential at 2 due to the dipole? It will be P cos theta by 4 pi epsilon naught r square. Till here, are you clear?
Yes, sir.
Now VA minus or V1 minus V2. V1 minus V2, this potential difference should be equal to, or V2 minus V1. V2 minus V1 should be equal to the potential difference generated by this field. You want the potential to be 0. That means potential difference between these 2 points generated by the dipole should be cancelled out or balanced by the potential difference generated by this field. Right? V2 minus V1. V2 minus V1 is 2P cos theta by 4 pi epsilon naught r square. According to the dipole, 2 is at higher potential than 1. According to the electric field, 1 is at higher potential than 2. Electric field is always from higher potential to lower potential. Now this should be balanced by what? This should be balanced by E into the distance. 2P cos theta by 4 pi epsilon naught r square. Field into the distance. How much will this distance be? 2r cos theta. 2r cos theta into the field. See if you are convinced. All you have to calculate is small r from here. Kp by E whole to the power 1 by 3. Small r will be P4 pi epsilon naught capital E to the power 1 by 3. See if you are getting the answer. This is a ring of positive charge. Of radius r. All of you know along the axis, if I displace the particle by a distance of x, a negative charged particle, I place it at the center and pull it out by a small distance, it will perform simple harmonic motion. Do you all agree with that?
Yes, sir.
Now here the question asked is, what if I place a charge q at the center, plus q, and then displace it in the plane of the board by a distance of x much smaller than r? What if I displace it by a distance of x in the plane of the board? Q is displaced in the plane of the ring. In the plane of the ring. Technically, bottom line, we never derived an expression for field in the plane of the ring. We only derived an expression for field perpendicular to the plane of the ring along the axis. So, if you can tell me the field at a distance of x, where x is very small, my job is done. Q into E is mass into acceleration. They are asking you for the time period. Find the time period of the oscillation. Find time period. To get the time period, all I have to know is the field here. Q into E is mass into acceleration. M is the mass of the particle. This is capital Q. So bottom line, you are assigned with the job of deriving an expression for field here. Once you get field, Q into E should be equal to mass into acceleration, which will give me the time period. Isn't it?
Yes, sir.
So you're asked to calculate the field. One hint I'll give you, you have to use Gauss law. One hint, you have to use Gauss law. Somebody is asking if the ring is insulated. Yes, the ring is insulated. Insulated. If not, the moment I move this charge, the charge distribution will change. The charge distribution is fixed. Now listen. Consider the cross-sectional view. You are assuming a Gaussian surface like this. Cylindrical Gaussian surface. Maybe I'll show it to you this way. You are assuming a cylindrical Gaussian surface like this. Cylindrical Gaussian surface with two approximations. If the ring is like this, I'll consider a cylindrical Gaussian surface. This distance is R. This total distance is 2L. That means the right distance is L, the left distance is L from the center. L is also very small, so that I am very close to the, if L is large, then you cannot assume that it is on the plane of the ring. L is very small. R is very small, that's given in the question. Rather here it's given as X. So I'll use it as X only. Don't change the symbols. This is X. X is very small when compared to R, and L is also very small. This is the radius R. This is the cylindrical Gaussian surface that you have assumed. I will redraw the diagram so that I can use it now. This is the cylindrical Gaussian surface. I slightly drew a bigger one. Change the color. Here I will take the field as K, Q, X, KQX, KQX. Here what is X? X is L. Here what is X? X is L. Along the axis upon R square plus L square to the power 3/2. Similarly, you will have the same field here, but on the surface, I am not worried about the field because E dot ds on the curved surface will become 0. E dot ds on the curved surface will become 0. This is the field. Now here observe this. The field will be radially inverse. Here, can I claim that the field will be radially inverse? Only then it will pull it back. If this field don't exist, the problem don't exist. The curved surface, this will be the field. This will be E on this surface, this will be E on this surface. How are you taking the expression for field along the axis? I am taking because the radius is very small and L is very small. X is very small, X is very small. So the field on the axis can be considered to be the field slightly above and below. net total integral E dot ds should be 0. What is the charge enclosed inside? 0. Now, field here into area will be pi x square into 2, this side and this side, plus field in the radial direction into the curved surface area 2 pi xl, right, should be equal to 0. See if you are convinced with this. Field radial into the curved surface area, this field into pi x square, this field into pi x square. Here I use the approximation. You gave me L is much smaller than R. You have taken that. Why should you take? Only then you are in the plane of this ring. This will be KQ by KQL by RQ. Now this field will be KQL by RQ. This into pi x square. This into pi x square 2 times. This radial inward field into the curved surface area 2 pi r. One correction, length is 2L. You took the length to be 2L. So substitute 2L here. Will I get the field in the radial direction inwards? Once I
Yes,
get
sir.
the field, Q into E should be mass into acceleration.
Sir,
Now,
but the approximation doesn't really hold, na? Because actual plane में रहने के लिए L has to be 0.
exactly.
And the solution, उसमें L being 0 will negate everything else, na? If L is 0, तो फिर E does not have to be equal to the solution we are getting.
Exactly. Whole of the problem will be null and void. So that is the difference between L tending to 0 and equal to 0. The so-called calculus. Here I will never put L0 in the numerator.
Yeah.
And physics, whenever we say something is very, very small, we should tell you with respect to what? My height is infinity when compared to height of an ant. My height is infinitesimally small when compared to radius of Earth. But technically my height is finite. So when you're comparing with something, L is much lesser than R.
नहीं, the question का statement is तो फिर not exactly है ना, क्योंकि उन्होंने बोला in the plane. Question is not making it apparent.
Slightly above the plane, that becomes a hint for the problem. Hence they told you in the plane. If they tell you slightly above the plane. Other than this procedure, you'll have to get into polar coordinates to find out the field in the plane. And in the plane you have field. The answer which you get
Field होगा.
matches 95% with the actual answer. So you can approximate this to be the answer.
Okay. Thank you.
Not defending the problem, this is originally from Pathfinder. Undoubtedly what you say has a point, but this solution is also equally valid because it matches 95% with the answer.
Understood, sir.
Can I rub the board?
Yes, sir.
You are giving this distance to be R. You are giving this distance to be R. This point is mass M. This is X. This is O. You have kept a charge of Q here. Kept a charge of Q here. Originally, the sphere was neutral. Initially, the sphere is neutral. Initially, the sphere is metallic, hollow or solid, doesn't matter. Metallic sphere. Initially, the sphere is neutral. They're asking you to find the field and potential at M. Field and potential at M due to the induced charges. Write down the statement. Find the field and potential at capital M due to the induced charges. Find the field and potential at capital M due to the induced charges. Field and potential at capital M due to the induced charges. Radius of the sphere is not given, implies it is not required. Somebody typed the answer, that's correct. No, field is quite easy. You will have induced charges. Negative charge comes over here. Positive charge comes over here. So it will produce induced charges, Q induced will produce a field here which is equal and opposite to this. All external charges put together will give us zero field everywhere inside. So field at M, net field should be zero. This should be field due to Q plus field due to Q induced. Field due to Q will be KQ by X. Field due to Q induced will be negative of this, KQ by X square rather, field. Right. So first bit is not a problem for anyone. To calculate the potential, I'll just rub this part of the board. To calculate the potential, first I'll calculate potential at O. Net potential at O will be KQ by R plus K integral dq induced by capital R. Capital R is the radius of the sphere. You said it will not be of any use for you. It is not given in the question. Yes, it is not. You will not need it. Observe this. Suppose you have got Q induced. Originally, the sphere was neutral. So when the sphere is neutral, net Q induced will be 0. From a neutral sphere, if negative charge comes here, positive charge comes to the other side. So net total charge on the sphere will be 0. So this will turn out to be 0. To calculate the potential due to the induced, I can calculate only at O, because only in the case of O, distance of all the charges from the center is the same. dq if I take from here, dq induced, any element that I consider is at the same distance from O. So hence I first calculated net potential at O. Advantage, it is equipotential inside a sphere. So this will be the potential at M net. We used why did you first calculate at O? Because every element is at the same distance from O. Hence you calculated at O. Now KQ by small r plus KQ induced by capital R. Q induced, if I integrate, it becomes 0. So net total I am left with only this. This will become 0. That's the reason why they didn't give you capital R. Now potential at M is potential due to Q plus potential due to Q induced. Now you know potential at M is KQ by R. KQ by R. Potential due to Q at that point is KQ by X plus potential due to Q induced. Take this to the left. Potential due to Q induced will be KQ by R minus KQ by X. Can I proceed?
Yes, sir.
This is a hollow hemisphere. This is a hollow hemisphere from which one section is removed. This I'll call it as theta. One section of the hollow hemisphere is removed. Find the field at O due to the remaining part left over. I'll call this sigma, charge per unit area. Find, it is a hollow hemisphere. Hollow hemisphere. Find the field at O when one section of this is removed. Sigma is the charge density, charge per unit area.
So when you say section, do you mean like an orange slice shape or?
Pardon, say that again.
When you say section, do you mean like an orange slice shape or like a cone shape?
One piece of a watermelon.
Okay, so yes, that's what I was.
One
Yes.
piece of a watermelon which we remove. First of all, do we know the net field due to the hemisphere at this particular point?
Sigma by 4 epsilon naught.
Sigma by 2 epsilon naught. Do I have to derive this? Is everybody aware of it? वो बता दो. हेमिस्फीयर के वजह से नेट फील्ड इज सिग्मा बाय 2 epsilon naught. Anybody who has a doubt in that expression, please raise your hand. All of you are very aware of it. Then life becomes easy. Now, because of the removed part, this angle will be pi minus theta. I will call this Z1, the leftover field. Removed field will be along this angle bisector. I will call this Z2. This angle will be theta by 2. Right? This angle will be theta by 2. Now this angle will be pi by 2 minus theta by 2. Pi minus theta by 2. So now have a look at it. So this angle is also pi by 2 minus theta by 2. Did I take the angles properly? When I place this piece back, the removed part ka field is E2, leftover part ka field is E1. E1 is what you are asking. Resolve both of them in this direction. Component of E1 and D2 in this direction. E1 component plus E2 component should be equal to sigma by 2 epsilon naught. Component in this direction. In the horizontal direction, these both should cancel out each other. In this direction, E2 component in this direction, E1's component should be equal. Component of E1 and D2 here should be equal. Sum of the two components in this direction is sigma by epsilon naught. From these two equations, you are asking me for the value of E1. Should not be difficult for you to calculate thereafter. Somebody typed, sir, this is the same as the one we did in the class. Is it? Good.
So is there some direct Gauss law solution?
No, Gauss law you cannot apply here. Because what Gaussian surface can we assume?
Beg your pardon?
Gauss law we cannot apply here because how do we assume a Gaussian surface? Gaussian surface assumption will be difficult.
Okay, huh.
So the sigma by 2 epsilon naught part is just derived by integrating the rings of the
Exactly. You are supposed to remember that expression. The sigma by 2 epsilon naught you will get by taking the field due to a ring. Consider an element. Consider an element. This is theta, this is d theta, this is r d theta. The radius is r sine theta. So because of the ring, find out the field at O and integrate this. You will get sigma by 2 epsilon naught.
So this was solid angle thing also wasn't working out. Same reason, Gauss law wala.
Exactly. Solid angle and Gauss law are in sync. One second. Now, listen carefully. There is one sphere. Another sphere. Now here, this is grounded. This is of radius R1. This is of radius R1. This is of radius R. This is of radius R2. Metal spheres. This is hollow. Those both solid or hollow doesn't make much of a difference. Two metal spheres of radius R1 and R2 such that R2 is 2 times R1. Let me make it a bit big. R2, given that R2 is 2 times R1, are connected by a thin, long conducting wire and has a total charge of 21 microcoulombs. Right? Total charge of 21 microcoulombs. 21 microcoulombs. R1 and R2 put together. Then R1 is placed inside a grounded metallic sphere of radius. R is 3R1. Initially, these both spheres had a total charge of 21 microcoulombs. Then the ball of radius R1 is placed inside a grounded sphere of radius capital R. Right? I again repeat, initially R1 and R2 had a total charge of 21 microcoulombs. Then this sphere is placed inside a grounded sphere this way. Find the charge that flows through this connecting wire. Find charge that flows through the thin, long connecting wire. Keep one thing in mind, specifically they emphasize that this wire is long. You know why I am telling you that?
No interaction between R2 and
R2 and
If not, इसका charge के वजह से potential on this will have to be calculated. First information is Q1 and Q2. You're telling me Q1 plus Q2 should be equal to 21 is my first equation. That was the information you gave. Second will be K Q1 by R1. This was before placing it inside the sphere. Should be equal to K Q2 by R. Kindly simplify both and tell me how much is Q1 and how much is Q2.
7 and 14.
7 and 4.
7 and 14. The Q2 was 14.
Yes, yes.
I'm banking on you. I didn't do the simplification. Now, again, I'll rub this part to solve the problem. Now, remember, I have Q1 here 7 and Q2 here 14. Now, when I keep it inside the sphere, grounded sphere, this and this may readjust any charge. I'll take X charge going towards the sphere. So the charge on this will become 7 minus X. Charge on this will become minus of 7 minus X, and this will be 0. This will become 14 plus X. If X charge went from the inner sphere to that, the charge on these two should remain conserved. Charge cannot be destroyed. They are not in contact with anything else. So if X charge went here, 7 minus X will remain here, 14 plus X will remain here. But what will be the charge distribution? This is 7 minus X, minus of 7 minus X, 0 here. Why? Because this is grounded. So 7 minus X and minus 7 minus X will cancel out on this. Why are you not taking the potential on this due to this? Long. That's the significance of long. Right? Now, the charge should have flown in such a way. What is the potential of this sphere? Now, X has gone such that this and this again right now are at the same potential. Potential of this sphere, K7 minus X by R1 plus K minus of 7 minus X by
3R1.
3R1.
capital R, rather 3R1. Due to this, whatever is the potential on the surface everywhere inside, it will be the same. That should be equal to potential of this K14 plus X divided by R2. Find X from here should not be a problem. soap bubble, you give charge to it, it will expand. You will use forces. Pressure will be sigma square by 2 epsilon naught because of electrostatic pressure. Surface tension pressure difference will be 2T by R. Third equation, you will apply P1 V1 equal to P2 V2 for the air trapped inside. Are you able to visualize?
Yes, sir.
Simple. All that you will remember, electrostatic pressure exerted by the sphere on any part of it. Pressure exerted by itself is sigma square by 2 epsilon naught. Remember this. And then surface tension ka pressure difference into area will be 2T by R. Third, for the gas trapped inside P1 V1. Why are you saying P1 V1 equal to P2 V2? Why are you not telling me P1 V1 by T1 is equal to P2 V2 by T2? For all these problems, temperature will be constant, because if temperature changes, surface tension will change. So they will give you the limitation. The problem becomes very bad if you change the temperature. So surface tension should remain constant. If not, the problem is bad. But till date, JEE never asked you questions on it. They have been asking you questions only mainly on shielding, grounding, and thing. Right? I believe day after tomorrow we have one more lecture in which I'll be completing capacitors and one part of current electricity. For that, equivalent resistance and equivalent capacitors are one topic for us. So capacitors and one part of current electricity, we will be doing it day after tomorrow's class. Day after tomorrow we have a class, right? I vaguely remember the timetable. 1 second, wait, let me see. Yeah, day after tomorrow, 10:30 to 1:30. (10:30 to 1). Capacitors and current electricity will be over in day after tomorrow's class. But how many of you are new students to me? People who have not studied from me, please raise your hands. How many of you are new students to me? People who didn't study from me. Please raise, I'm seeing the numbers. Six. Okay. Yeah. Saturday's class, I'll send the recording also. Even today's class recording, I'll send it or I'll upload it on the YouTube. Fine.
Sir, can you please show the QR code?
Of this, yeah, that sounds better. QR code. Share. QR code. Share.
So can we leave?
Yeah, yeah.
Okay.
We're done
Thank you
with
so
the.
much.
Sir,
1 second, wait. Yeah, bolo.
sir, do you know when we will have doubt lectures? If we have any doubts in the papers which we are solving.
Listen, they have put up a doubt lecture schedule. 1 second, wait. I have that. Gautam told me he put up doubt lecture schedule. If this changes, I'll keep you people informed, but wait. 6:30 to 8:30 in the evening, Monday, Wednesday, Friday. Confirm with Gautam again, right? Or they'll leave this in the group from next week. Monday, Wednesday, Friday, 6:30 to 8:30 p.m. Doubt lectures.
Okay, sir. Thank you, sir.
Good day. Bye. Thank you.